YouTube content creator and a social media influencer. So let's go back with the redox topic, reduction, oxidation, chemical reactions. Okay, so I'm gonna discuss redox solution. Wow. Redox solution can either be redox in acidic solution and redox in basic solution. Before going to some examples, we need to give you the different rules how to do it and how to have the redox chemical reactions in acidic solution and basic solution. And of course, we need to discuss first redox in acidic solution, then followed by redox in basic solution. Okay? Init king coffee do. Char. Okay. Ganon. So, it's very clear in the whiteboard, right? Okay. So redox solution, okay, redox in acidic solution and redox in basic solution. We go first for the redox in basic solution. Okay? Like this. Redox in basic solution. Thanks for watching my vlogs and my live streamings. Okay, my revenues are working well. Okay, with a little bit of increase daily ala tool, something like every day. Okay, redox in basic solution. Okay, like that, and then there's no trending videos, but I just recovered it by having multiple vlogs in daily basis so that I can cope up with the revenues issues, okay, because I'm not popular, I'm not famous, so it's only like that. Okay, so it's very tiresome, but you need to have to put extra love, dedication and passion in doing your line of expertise, okay, something like that. To get the point. Okay, coffee first. Oh my gosh. Okay. Now, as you can remember, I talked to you guys, okay, the identifications of the redox. First, all combustion chemical reactions are redox chemical reactions. Secondly, all double displacement, okay, like that. No, single replacement rather. Single replacement and single displacement are all redox also. Okay, and then a mixture of elements and compounds like that, and products also composed of elements and compounds are also redox. But element to element and the products to our elements are not redox. Compounds to compounds are not also redox. Meaning compounds, okay, the reactant, and then compounds also are the products are not redox. Meaning to say there's a combination of elements and compounds, blah, blah, blah. Okay? Or elements not a redox, all compounds are not a redox. Okay? Get the point. Then for combination synthesis, sometimes a redox, sometimes not. Okay? And then for decomposition, sometimes a redox, sometimes not, and you have to evaluate. Okay? Like that. Okay? And also, double displacement and double replacements are not redox because it composed of compounds, no elements, such as the hydrolysis reaction, the neutralization reaction, like that. Okay? Get the point. And your identification for a redox, guys, there must be a polyatomic ions in your reactants or an oxides of metal in your reactant. Oxides of metal, for example, sodium oxide like that, magnesium oxide like that with oxides, okay, or polyatomic sulfate, permanganate, manganate, sulfate, dichromate, negative ions also in the reactants. So it is really a redox, and then there's also an element in the reactant, okay? Or an element in the product and a compound, as long as it has combination of both elements and compounds. Okay? Okay. Now, technique. The technique is, this is the rule. Okay. So number one, we need to obtain the oxidation number of oxidation state. Oxidation. Okay. Oxidation number and oxidation state. Okay. like that. Okay, number 2, determine whether determine the oxidation chemical reaction, determine oxidation, okay, oxidation and reduction. Okay, so we have the uniform oxidation, loss of electrons, okay, and the reduction gain of electrons. Okay, loss of electrons meaning there's an increase of oxidation state, okay, or number, okay, and then for the gain of electrons there's a decrease of oxidation state, okay, and oxidation number. Okay, number 3, guys, you have to balance. Okay, you have to balance the oxidation, okay, reaction and reduction reaction. Okay, like that. Okay, first unit 3.1, we need to balance first the number of atoms. Wow, number of atoms. This is not the ordinary chemical reactions that we are only focusing to the balancing the number of atoms. No charges. Here you have to balance the charges. Number of atoms. 3.2, the number of charges plus the addition of electrons to balance it. Okay? Number 4, in the oxidation or reduction, it depends on the situation. Oxidation or reduction, after you balance it by number of atoms and charges and electrons. Oxidation or reduction, for example, if you have a polyatomic with, usually with oxides are the best example for this. Okay? So oxidation or reduction, so with polyatomic anion with oxygen, okay? Okay, with oxygen or metal oxides, any, okay? So, add water if there is a deficient of oxygen in the left. Add water to the right. If there's a deficient of oxygen in the right, add water in the left. With corresponding adding of H plus in the other side. Okay? So, adding of water, okay, to the oxygen deficient side. Okay? Oxygen deficient side. Okay? And then with equivalent plus H plus on the other side, and H plus hydrogen positive on the other side. On the other side. Okay, meaning to say, guys, so if we have to add 2 moles of water in the right, you have to add 4 H positive in the left, because 2 moles times the subscript 2 is equals the atoms, 4. So 4 atoms of hydrogen H plus. Okay, so I may specify here H plus and then water, H2O. Okay? So number 5, only 5 procedure for this, a rule. We have to add, okay, add the oxidation half reactions. Okay? The 2 oxidation reaction you have to add. Okay? So meaning oxidation reduction is really the half reactions what we mean here. Okay? Oxidation half reaction, the reduction half reaction, oxidation half reaction, you have to add the 2. Okay? And then the electrons will be multiplied by something to equal that one so that you can cancel that one. So your last redox chemical reactions have no electrons in the final. Okay? That's the procedural rules 1, 2, 3, 4, 5. Now this is for the basic acidic solution. Now for the basic solution, it's very easy. You do first the acidic solution, and after that in your number 5 step, you have to add OH in both sides. For example, if you have 4H in the left side, you have also to add 4OH to the left side. So it will become 4 moles of water. And the other product also you have to add OH there. And then if there are similarities in the compound, you have to subtract or you have to cancel, then it will be simplified further. That will be your final redox chemical reaction. Okay? Any questions so far for the a brief introduction of redox in acidic solution and redox in basic solution. Okay, any questions so far? Thank you so much for listening for this introduction of the redox of the solution. You can comment down below in the comment section. You can like and share if you want also. And then if you think you are not subscribing yet my YT channel, then you can subscribe, and I am very happy to that. And then you can click also the bell notification for some news updates of I am a singer later of course. Bye bye, God bless everybody. See you later for the examples. Okay.